Hello and welcome to Evolving Code. My name is Naresha. In the last episode, we learned how string concatenation using plus operator works under the hood, and we saw how the underlying API changed from string buffer to string builder in Java 5. In this episode, we will understand how performance problems occur in string concatenation, and by observing the evolution of string concatenation implementation, what can we learn about making our application or code more evolvable? We'll find out. Well, now that we understood how concatenation using the plus operator works with two arguments over Java 1.4 as well as 5, let's understand the performance intricacies here. So we have seen how first plus second works. Similarly, if you have more arguments, plus third, plus fourth, like that, in that case you would see the append chained append call will happen after append second, dot append third, dot append 4, like that. So in this case we haven't faced any performance challenges. What we will try to do is introduce multiple statement. That means the concatenation happens across multiple statements. Let's take an example. So I have created a method concat2, which takes two arguments, but now you would see that concatenation happens across multiple statements. Technically here there are three values: empty string, first, second, and the result is a concatenated string of all these three values. And we start by initializing the string value to empty string. Then we are doing result plus equal to first, which is like result equals result plus first. Then we are adding second. Then we are just returning the final result. So now that we have split this concatenation into multiple statements, would that make any difference? Let's again compile the code, compare the bytecodes, and see what happens. You are seeing the bytecode for concat2 method along with the Java code on the right. Let's see how the change, that is the concatenation across multiple statements, is making an impact on the generated bytecode. Let's start with the first line, that is the initialization of result to empty string. You would see here this is the equivalent, like loading the constant and storing it on the local variable. Let's move on to the next one, where we concatenate result plus equal to first. So we have already seen how concatenation of two strings work, which is available in the beginning of the screen as bytecode for concat method. So if you compare the bytecodes within the highlighted block here, they are exactly same as what you have here. So we first start by creating an instance of string builder. Then we concatenate the first string, then we concatenate the second string. Finally, we convert the string builder object to string. And finally, there is an additional statement to store the resulting string into the variable result here. So I hope you are able to see that this code, the highlighted part here, is exactly the same as what we have seen before. Let's move on to the next line. which is very similar in nature. So, the same set of code is repeated here, except that we are concatenating the value second here. That is all the change would be. So, if you see a load 3 here, here it was 1, here it was 2. That is the only change, and of course, we are storing the result back to the same variable, which is result. Now that the concatenation has spanned multiple lines, you would see how it is making a performance impact. So, we have created multiple instances of string builder, and at the end we are converting it back to string. These are the additional instructions here, right. Suppose you had multiple arguments, string 1 plus 2 plus 3 plus 4 plus 5, anything like that, then all we need is just one string builder object, and we keep on calling the append method. Then finally, we have the return statement, which last 2 bytecodes are corresponding to the return statement. So, now I hope this will help you to understand how complexity or performance challenges occur when string concatenation spans across multiple statements. Now, I hope you will be easily able to relate this to concatenation which is happening within a loop. So, this code is as if the loop which is happening twice is being unrolled. Imagine this happening several times, because say the code is getting called from a loop, and the performance impact of that. If you find it a little bit hard to understand these bytecode, don't worry. Right away I am going to give the Java equivalent of that, which should help you to understand the situation if you are not able to follow the bytecode. Here in method concat 3, we have the equivalent of concat 2. The only difference is that concat 2 is written using the operator plus, and concat 3 is written using the underlying API calls, that is the string builder dot append. I hope that helps you to understand the code better. So, previously saw the concatenation operation was very primitive in nature. Let us look at more real world use case of where we really need to move away from concatenation and make use of these string builder or string buffer classes. I have the class command executor. Right now I am using the the operator plus based concatenation here, which is responsible for executing the commands given to it. Like I am creating the instance of that, and I am giving like 1000 times different commands to execute, and each time we will keep a log of what command was executed by this command executor. So, initially I am using command log as string, and every time it executes I will increment the count by 1, and initially show the command number followed by a colon, then actual command, then the next command will be in the next line. Finally, I have the method get command log, which will return this string. If I run this, you would see it will print all these commands. Say first command followed by the index starts with 0, that's why it is 0 here. That's what it is. In this case, you will see that we are not sharing this across multiple threads. That's the use case what you are seeing here. So, let us make use of string builder instead of string buffer. Instead of string, we have chosen string builder. That's why we'll have to assign it an instance of string builder, and then we will make use of append here. And previously it was already string. This time we'll have to convert string builder object to string. That is pretty much change here. But something interesting you will see here, that Previously everything was using a concatenation operator, so it was okay, but now we are having using append, and you would see that still there are a couple of concatenation operators used within the append call. If you are just concatenating 2 or 3 strings in line using plus operator, it would have been absolutely fine, but since we already have a string builder object created, there is no point in reducing the performance using these additional pluses. We could just make use of the sole string builder object. So if I select this here, IntelliJ is automatically recommending me this. So all the append all the concatenations are replaced with the append call. The reason why this happens is append accepts a string argument here, and when you create a new intermediary string builder there, it has to be converted back to string. That way it will cause slightly reduced performance. So these are the typical use cases where you are calling execute method thousands or millions of times, and in that case by using a string builder here will improve the performance. To conclude, first I would like to reframe the suggestion from effective Java slightly as follows, because the use of combine more than a few strings can be a little bit not very specific. So I would say that typically if everything is in one statement, then you could make use of concatenation operator. Then if it spans across multiple statements or over a loop, multiple method invocation, in that case if you need thread safety, make use of string buffer, otherwise make use of string builder. This would be purely from the performance point of view, but there is a catch. What is that catch? If you look at both the approach, that is using the API versus plus operator approach, plus operator is at a higher level of abstraction compared to the API call, that is string buffer or string builder. In Java, when you compile the code with the plus operator, the compiler will use the appropriate API. We have seen that in 1.4 version of the compiler, the plus operator was getting converted to string buffer API call, whereas in version 5 onwards, plus operator concatenation was getting converted to API calls of string builder. That way, if you stay at higher level of abstraction, you have the benefit that Java can internally optimize and choose the best API for you, and without you making any changes in the newer version, your code may be working faster. So when it comes to using Java, always try to pick higher level of abstraction and not a lower level of abstraction most of the times. If specifically you are in a situation to improve the performance or something like that, then you might leave this thumb rule and might use the lower one of the lower level of abstraction. I would say this is the biggest learning from what we have seen, the evolution of strings or string concatenation specifically from Java versions 1.4 to Java SE 5. The evolution of Java specific to strings or string concatenation does not stop here, but we will end the episode at this point in time. And let me leave you with this interesting thing. Now that we know you have to favor a higher level of abstraction, not a lower level of abstraction, for those who didn't learn from these mistakes, Java again came back with the change and made the people who did not favor the higher level of abstraction suffer. How did that happen is a story for another episode. I hope you found this episode useful, and see you in another episode. Have a nice day.